Good day, everyone. I'm Wong Zihong, and along my side is my colleague Wilson Lim Yongjun. Now we are taking the BAIT 2004 Fundamental of Computer Network, and we are both from RSD1 Century Group 1. We're thrilled to discuss our project on local area network, which is of the lifeblood of digital communication in our interconnect world. Today we're delving deep into the implementation of LAN within a corporate environment, specifically at Sri Muda Goat. Our task is to design, implement, and test the addressing scheme for the company, ensuring it is suitable for the company and the network topology is fulfill the company requirement. Let's begin with the core of our project, address design. In a dynamic corporate setting, addressing design must be efficient and scalable. To achieve this, we employ variable length subnet masking or VRSN. This technique allows us to assign subnet masks based on the actual needs of each department, ensuring precise allocation of IP addresses. By using VLSN, not only do we optimize IP address usage, but we also enhance scalability, flexibility. This approach significantly reduces IP wastage, which is crucial for the sustainable growth of the network infrastructure. The company requirement, we must calculate more 30% horse needed for the future growth of the company. Horse needed. So now we show VRSN table. In this network design, we decided to use Class B subnetting to allocate the IP addresses and use private 0.16.00 as the purpose of creating this network. So this is the VRSN table that we help the company department to assign the IP address. We arrange the VRSN table by the prefix like from /24 to /30. Depends for the host needed. The next is network topology. Moving on to the network topology, our design cooperate with the 4 routers and 15 switches across 4 buildings. Each department we assign to 3 end devices for it. Each department within this building connect through its designated switch the main router, so forming a star topology. This setup not only facilitates inter-visual lane routing but also ensure robust security and performance by segregating traffic. Each department is segmented into their own subnet, allowing for controlled access and efficient management. All router is also connected to other buildings, router facilitating the interdepartmental and inter-building communication. So for the next is addressing table. Here is the addressing table of us. We call it Wilson presentation time.
Okay, so now I would like to talking about the network configuration. First, we're going to set up our PC IP address and default. For example, the switch one management department has 3 hosts. So it's let's call that. This should need to tag for switch 1 to 15. Okay, now we're going to assign a password to the switch. First, we're going into our privilege mode and we set the host name for the switch, which is switch 01. If the switch 2, then we will set the switch 02. And then we insert a password, which is Cisco 2024, and we enable the secret password class 2024. After all, we also set up the banner, which is this is a secure system, authorized access only. It will popping out if the user enter a wrong data. Then we exit, and then we save the command that we type into it. So this session also need to take it from switch 1 to 15. Okay, now we move on to the configuration on router. We assign the password on it. So we set the host name, which is router 0, and the password is for 2024, the secret password plus 2024, and the bandwidth still the same. We save the commands. So this actually is only to tap from router 0 to 3. So in next section, we're going to assign the IP address into the switch. So we're going into the interface virtual LAN 1 and the IP address assign it to 172.16.8.2 and followed by the subnet mask 255.255.192 and we shutdowns and we assign the IP default gateway for it, which is the router IP address 172.16.8.1. Then we end. So now we're going to configure our router IP address. In router, there are a lot of devices connected to the router. So this is the interface that connected router to another devices. For example, we go into the interface gigabus 2/0. We assign the IP address 172.16.3.1 and followed by the subnet mask 255.255.255.0 and we shut it down, exit, and we go into another configuration for another interface. So here's the all. So now we're going to test our ping connectivity in our packet tracer. Okay, here is it. In our packet tracer, we have 4 routers and also the building A, B, C, and D. So now we're going to test from building A PC15. We're going to connect to the PC3. Also stay at the building A. So we're going to test using the command prompt. Still the same. Go back to the destination IP address. Basically, first time going to click the address will come out with the request timeout, so we need to type another time. So obviously the result come out and it was 4 send and 4 receive. So now we're going to test the different buildings. So we're going to test from PC15 ping to PC42 at here, building D. Still the same through the ping, followed by the destination IP address. So mostly the result 4 send, 4 receive, and 0 loss. So the connectivity is there. Now we're going to connect PC15 to building B PC24. Copy the IP address and command prompt ping it. Okay. So that's all for my presentations. Okay. Okay.
Thank you.
Okay. So the connectivity is there. 4 send, 4 receive. Then move on to another PC15 from building A. Connect to building C PC27. Hit the IP address. Then we put inside the PC15 command prompt. So thank you. That's all.
So thank you for our thank you for our teacher. Chắc chắn đấy.
Take some time.
Đồ ăn xe miên.
Okay, we try again.
Thank you for concentrating for looking to our video.
Okay, for send, for receive, and
Okay,
so that's all for my presentation.